Hello, and welcome to this exciting video where I'm going to go ahead and show off the MIT PCIP that I'd been able to rebuild from source. So let's just show part of it in action, where you can see I can ping my emulated gateway. So let's take a moment because it's coming from virtual floppy, and there you go. You can see ping the host 4 times, got 4 responses. Awesome. So just to show the settings here, if you go into network, this is using the SLiRP library, which is a user mode TCP/IP stack. So no device drivers are required. You just basically turn it on, configure your network on the appropriate network on the settings, and you're good to go. One thing you might notice is that it says the host is 12022. It's using commas because this old stack likes to use octal. Binary, decimal, hexadecimal, and then in the middle is octal. Octal is base 8. So yeah, it makes it makes life interesting to jump between all these different types of settings. If you look in the MIT directory on this floppy, we can see that there's the custom program, which is how you configure how the network is set up. So you actually customize the device driver, which is a little scary. Divide overflow, and that's the other thing. When you run programs under this thing, it crashes all the time. So yes, you do have to reset the emulator constantly. It's apparently it was a problem back then, so I'm not too worried about that. So if we look into the configuration, any moment, this is just local site stuff that we're interested in is the site customization, and you see my internet address 12027. So if we bring up the calculator, so how does 15 become 17? So 15 is decimal, and then we bring that into octal, we'll get 17. Just like in decimal 10 is octal 12. It gets so confusing sometimes. So as you saw, we were able to ping the gateway. We do it again. And then what I've noticed is that if you haven't restarted the emulator, it will only have worked once. So this will fail. Any moment. It's very slow. There. So you cannot send. So we'll just go ahead and kill the emulator, fire it back up. I'll ping the gateway again. And you can see it responds. But if you do it one more time, I believe it will not work. So part of the problem is that the MIT stack does not like the SLiRP library, and the SLiRP library does not like the MIT stack. Of course it works this time. But if we try to telnet to that BBS on the internet, I think we're going to hard lock, aren't we? Yeah, we're hard locked. So let's just try this one more time. At least restarting the emulator is very quick. And then we'll see that it's not going to work. And this is basically as far as it's going to get. It's going to go trying. You'll see the little Ethernet thing blink occasionally. Come on, blink. There you go. But yeah, it's not going to work. So before I get too far ahead of myself, I'm using 86 bucks as the emulator, as you can tell. I've managed to build a custom version of MS-DOS 2.11. What do you call it? Microsoft has open sourced this under an MIT license, which is nice, so I can redistribute this DOS as much as I want. This is the project for the MIT PC IP tools, source code, everything you need to get this thing running. Later on, we're going to use my port of the Dynamips, the Cisco emulator, to Windows. There's some fun tools in here as well that we're going to use, which is another version of the SLiRP library that can run standalone. We're also going to use my port of what was known as the HecNET or DecNet tunneling support, which lets you do layer 2 tunneling. And finally, to build this all together, just to show off, I guess, the build process for the MIT compiler, we're going to use the Win32s 1.1 Visual C development because it's incredibly tiny. And yeah, I guess just for completeness sake. Alright, so as we go back to our DOS PC, we can see it did not work. So part of the problem is we have zero visibility into why this didn't work. Why did it stop failing? I don't know. Nobody knows. It's impossible to see because it's a black box. So just to kind of illustrate what's going on right now, we have our virtual machine. We have our networking library, the SLiRP, which is built in, and then that in turn can talk to the internet, as it were. On most drawings, you use lightning bolts to represent WAN links, so that's my side, lightning bolt. So it's some text. So this is 86 box MIT PC IP. This right here is the SLiRP library. Let's move that over a little bit. There we go. And just think of this as being the internet. So normally with SLiRP, you would configure your PC with the address 10.02.15. The SLiRP library listens on 10.0.2.2 for the gateway, and 10.0.2.3 for DNS. And then the internet, well, that's the internet. That's basically everything. So I'll just treat it as a wild card. Although I guess to be technical, let's give it the proper class address. It's usually just 0.0.0.0 with a mask of 0. So basically everything lives out this way. So again, the SLiRP library is compiled into the 86 box application. So to see what is going on in here, this being, of course, our big question mark, we have no visibility, no idea what's going on in there. So what we're going to do is we're going to go ahead and take this configuration and we're going to rebuild it so we have our, once more again, 86 box MIT PC IP. Oops, like that. But this time we're going to add a loopback adapter on our physical Windows 10 machine, so that way we can now attach WireShark. Let's give WireShark a diamond. This is not going to fit, but it's okay. Wire and shark. It's good enough for now. Then the next thing we're going to do is we're going to use that HecNET program. So we'll give that a different shape. And the HecNET thing is a layer 2 bridge. So it's just going to see packets here on this network, and it's going to copy them out through UDP. So it's HecNet NT. And it's going to have a UDP connection on the host machine. And we're going to call this one here SLiRP redirect. And this will in turn talk to the internet. Go ahead and put this here. This is going to be the Windows test loopback. So we're not going to change any IP addresses. So the 86 box will still be 10.0.15. And then our SLiRP library, which we can just copy this, copy, paste, is going to be here. So if you can visualize it, we're going to take this SLiRP library, we're going to remove it from being compiled into the application, the 86 box, and we're going to use this HecNET NT library, or bridge program, to then forward those packets to the SLiRP redirect. So as the packets enter this test loopback network, WireShark is going to be able to watch them. So this is going to give us visibility into what on earth is going on. Hopefully this makes some sense, but you know, as always, the fun is in building it. So the first thing we're going to do is we're going to go ahead and add the loopback interface. So we go into Manage Computer, the Device Manager. Make sure you click up here, and it should be Action, Add a Legacy Device. Now we know what we want, so we're going to add the manual. Then we're going to come down here to Network Adapters. We're going to scroll down to Microsoft, and we're going to go for this one, the KM test. So it's Kernel Module Test Loopback Adapter. And then just hit Next a few times and finish. And now we should have our testing loopback adapter. Alright, so we can close out of here. Now we just want to, or at least I want to remove all the Windows stuff from that adapter. So I just type View Network Connections. And this will bring us back to this legacy view. I'm going to first rename this because it's a terrible name. I'll call it KM-test. And then we're going to go into Properties. So Windows itself does not need to talk on this thing. It's all going to be programmed using WinPCAP. So I'm going to remove the client, the file and print sharing, TCP/IP4, and TCP/IP6. Everything else can stay. So now this adapter has nothing bound to it. So if I bring up a command prompt, type in ipconfig, you can see I'm only still connected to my home network. There's nothing in here for the adapter. The next thing we need to do is, of course, we need to download WireShark and install it. I've already downloaded it. So we can just go ahead and run this. Let's see what's going next. Right, agree. I just go with the default settings, it doesn't matter. We do need to install npcap if you don't have it already. Do not need the USB. And this will start the setup, and then it will kick off the setup for npcap at any moment. Okay, so at the npcap setup, we do need to make sure we install the WinPCAP API compatibility mode. And then this will do whatever it's going to do. Alright, so the setup of the npcap is complete. And now it's going to finish installing WireShark. Okay, so with that installed, we can just go ahead and next to finish this part. And we have our WireShark installed. Great. Now, the next thing I guess to look at was in the downloads. I did download the HecNET program already, so this is a layer 2 bridge. And I've actually already installed it. Well, there's nothing really installed. You just, grab the files, copy, paste. Yeah, it doesn't matter. But we do need to configure it. I've made a simple configuration where it's just got the loop, and then it's going to update another program, which will be the SLiRP library. And then the bridge is what picks up for L2, and then the TCP/IP part is what picks up for L3. So it's going to listen on everything on these adapters, and then if it sees TCP/IP traffic, it's going to bridge those together. If you go through the README, you can see it supports HecNET as the original example. I supported IPX and some other protocols. I forget which. I think AppleTalk. But the big thing is that what do you call it? That I added stuff like compressed bridges. That was it, the C bridge versus the regular bridge, and all kinds of other fun stuff. But most people didn't care, so this program was not a success. If you run the Ethernet list program, this is going to show where these weird numbers come from, the network interface GUID. So in this case, the one that we renamed KM test, that's the one we want. And this is going to be the GUID for it. It's going to be unique for everyone's system. No two systems are going to be the same. So I can't just give this to you. Unfortunately, it just doesn't work that way. So that'll configure the bridge. So let's just go ahead and look at these things. So it's literally just going to listen on port 5000 for UDP. There's really not that much to this thing. It's very simple. So if I run this, it's going to want network access. So that's fine, public, private. And when you run the bridge, you can see that it's listening on the PCAP interface, and that it's going to go ahead and forward packets to the same IP 127.0.0.1 on port 5001. So now, if we go back to my downloads, I've already downloaded the Dynamips program. I just make a directory, see Dynamips. And again, nothing too exciting. You can just sort by type and then just grab the executables, copy from here, paste to here. It's the exact same programs. And I should, I guess, just mention that the Dynamips came from the SourceForge, and the HecNET also from SourceForge. I'll put links in the description. In this case, we're going to use the standalone version of the SLiRP program. So if we go into Dynamips, and then we look at the command file I've already set up, so you can see that the bridge here sends on port 5001. The SLiRP redirector is going to listen on port 5001, and then everything that it's going to transmit, it's going to send to 127.0.0.1, which is the Windows host itself, and it's going to send it on port 5000, which of course, if you remember, that's what the bridge listens on. So these two programs are going to be set up so that way they talk to each other. So we go ahead and run that, and then Windows Defender is going to do its thing. We give it access. So now we have these two programs running. The important thing to notice here is that when the bridge sees traffic, it's going to update its table. I know this is going to get confusing with so many screens, so let me just try to separate this off. I'm going to make a new desktop. And what we're going to do here is we're going to go ahead and run WireShark. This is just installed here. And then you'll see it's going to list the interfaces. We're interested in KM test. Nobody's talking right now, so there's no traffic. So if we go back to desktop 1, you can see no hashes, no transmissions. Okay, so let's make another desktop. Now we're going to go ahead and start our machine. Now we're going to go into its settings, and we're going to reconfigure its network. So instead of talking directly to the SLiRP library, we're going to go talk PCAP, and we're going to make sure we're using that KM test loopback adapter. We're going to save our setting, and we're going to boot from floppy. And we're going to go ahead and try to ping the gateway. And I believe this doesn't work, and it's just to show that the packets are getting across the wire, but these two programs, the MIT PCIP and the SLiRP, they really do not like each other. So here's, again, what you would see sometimes, it's just can't send. So what's going on? But because we have that loopback interface, and we have WireShark, we can actually see the packets. And in this case, we can see that the MIT broadcasts out who has 10.0.2.2, tell 10.0.10.15, and then the SLiRP library replies, here I am. But for some reason, it's not ingesting this packet. It's the fundamental flaw. So I guess one way to try to work around this is to hard code the MAC address in the ARP table. So if we look, the MAC is 52.54.00.12.35.02. If we go back, I guess just a view over here on the bridge, you can see that the bridge has learned both entries. The 52.54.00.12.35.02, that is the SLiRP library. And 02.60.8C.59E1.8E, this is the virtual PC. And you can see, as far as SLiRP is concerned, it sent and received traffic. But yeah, the PC doesn't see it for some reason. So we're going to go ahead and reboot first. And we're going to go ahead and build the MAC address entry. So it's custom net dev. And this is going to be the awkward part because it's going to be in octal. So we go into the hardware setup, and then we want the Ethernet Internet Translation Table cache, and we're going to go ahead and create an entry. So enter the IP address, so it's 10.0.2.2. And now it wants to know the Ethernet address. And if you see, these are all commas. So it's going to be octal. So let's just give it a bogus one. So luckily, it did pick up the decimal to octal here, but for the Ethernet, we got to do this manually, I believe. So 10.0.2.2. Let's try it with periods. Maybe it'll pick up 52.54.00.12.35.02. And the answer for that is no. No, it did not. So we've got to convert these into octal. And for that, that's why I keep an old copy of the Windows calculator handy, because it'll happily do this. So the MAC addresses are hexadecimal. So first value is 52. We go into octal, so it's 122. It's 122. And bring back the calculator. Just do this so I can kind of like not lose it every time. So we go hexadecimal. So the next value is 54, which in octal is 124. 124. And then dot. And the next value is 0, so that's just 0. Oops. 124.0. The next one is a 12. So hexadecimal 12 is 22 in octal. The next value is 35 hex. Then in octal 65. Dot. And then the next value was just 2. So 2 is going to be the same in octal and hex, just 2. Because it's lower than 8. So we hit enter. So this should be our MAC address converted into octal. We're going to return, and we're going to return out of here. Then we're going to exit and save. And actually, I don't think we need to just do a full power. We'll just do a reset. And we're going to go ahead and try to ping the SLiRP library again, ping 10.0.2.2. So now there's no ARP, because we've removed it. It's going to be static. And if we're lucky, these two will reply. If we're unlucky, we'll see the traffic on the wire. Alright, so it pinged the host 4 times, 4 responses. So let's go to WireShark. And you can see from the time this was when it was trying to ARP, now that it knows the MAC address hard-coded, it can go straight to the ping. And you can see the data is just kind of garbage, but it sends nonsense, it gets nonsense. So there's our ping capture, definitely working. So I'm going to stop this capture. I'm going to do a new one. And then we're going to go back here just to verify that no new MACs have been learned, and you can see the SLiRP library is still sending and receiving traffic. So I'm going to go back to my MIT PC, do a hard reset. And now we're going to go try to talk to the BBS. And you're going to see that fundamentally, once more again, these two things really hate each other. And this is not going to work. Just take a moment. Okay, so the program's up, it's trying. We're going to toggle back to the sniffer. And you can see it's going to send the SYN packet. It gets a SYN-ACK, but again, it does not like the SLiRP library, so it keeps retransmitting, hey, are you there? There? And of course the PC doesn't respond. It says, I sent a SYN packet. And the SLiRP library on its behalf is saying, yeah, I acknowledge, but they're not seeing each other. For some reason, they have some weird problem communicating. It's probably a version thing or some other weird bug, but for now, I didn't want to mess with this. Basically, just leave it as is. There's no point trying to troubleshoot the MIT stack from '85. It's a vintage thing. It is actually working the way it's supposed to. So we can exit this. So the next thing to say is this configuration even working? Which would be the usual thing, like maybe this setup isn't working correctly. So I'm going to go ahead and close the bridge and the SLiRP, fire them up again, just so that they're starting now from a new state. Make sure my packet capture is going. And then if you saw, I had a Windows NT 3.5 workstation, so we're going to go ahead and use that. I've previously set this thing up, so its configuration, of course, will be slightly different for the network. Because again, with those GUIDs from the Ethernet lists, this changes every time per machine. So you really can't pre-configure those. But I've pre-installed the operating system, so we don't have to watch me install Windows NT from Flock. So NT boots, and we should get the login prompt perfect. And we're going to go ahead and try to ping the gateway, ping 10.0.2.2. And we're getting replies, which is great. We come back to our sniffer capture, and you can see there's tons of traffic, including this thing doing an ARP announcement because NT is different. The stack knows. We can see the ICMP packets. Windows is very talkative. It's wanting to constantly announce itself onto the network. And if we go over here, we can see that the bridge has picked up the traffic and that SLiRP has learned and is talking to Windows NT. Okay, so what about a TCP connection? I set up that same BBS prompt here, so if I click this, and we're connected, just like that. So I've shown you a negative, and now I've shown you a positive. We right-click on any of this, follow TCP stream, and we can definitely see that the Windows NT is talking across the network. So going back to our lovely diagram here, the MIT thing did not work. And it's going to be a problem with the protocol based in here. So just remove this. And then all we did was replace this with NT 3.5. And this setup was working. So how do we get the MIT thing to work? That's going to be the fun question. So let's clear all of this and try a new configuration. What we're going to do is we're going to still have our 86 box MIT TCP/IP, and we're going to still have it on a virtual Ethernet. And this time what we're going to do is we're going to add a Cisco router, and then that Cisco router will in turn talk UDP to the same PCAP library, and then that PCAP library will in turn talk to the internet. So let's add some lines. Oops, not that. Sorry, line. Or a little lightning bolt thing. It's going to be connected to here. This will connect into here. And then of course we can have our WireShark. Let's use this shape this time. Alright, so it's label. So this is 86 box MIT PCIP. We have WireShark. We're going to reconfigure this LAN to be a different network. You're going to be 192.168.1.0.24. You're going to have the .5. Cisco is going to be the .1. So we'll just say Cisco / Dynamips. This will be the SLiRP library. You're going to talk over UDP. Call you the internet. So this is where the 10.0.2.0.24 network is going to live. And the Cisco Dynamips will be the .15. The SLiRP library here will be .2. And our friendly internet, of course, is everything else. Okay, so in this example, we're going to reconfigure 86 box to use this 192.168.1 network. It's going to talk to a virtual Cisco router, which in turn is going to have a connection through UDP to the SLiRP library, and then from SLiRP. So this is going to be a little bit more involved, but not too ridiculous. This is this thing beeping at us. We don't care. You know what? It's all. I've got copies. You can just turn it off. Doesn't matter. Stop. Doesn't matter. Just leave it alone for now. So back to our drawing, ignoring the beeps. Okay, so 86 box is going to have a different network. We're going to add in this Cisco router because I'm pretty sure that the Cisco router and the MIT PCIP will get along just fine. So part of the thing which I didn't really illustrate is that when SLiRP picks up traffic, it's going to do something called NAT. And let's give this a, I guess, a wild color like blue. So NAT is network address translation, as the 10 network doesn't work on the internet. So everything coming from this address is going to get hidden by the SLiRP library, and the SLiRP library just acts like a normal client on the network of the machine it's running on. But the problem is that the SLiRP library, I don't know how to talk to the routing, so I can't tell it about this 192 network. So we've got to turn another layer of NAT on, and that's going to be from the Cisco router going towards the SLiRP library. So this is going to be, in effect, double natted. So the MIT box is going to have this 192 network. The Cisco router is going to turn that into its 10.02.15. And then the SLiRP library is going to take those 10s and then speak over the LAN, whatever the host PC is using. Which, believe it or not, is also 192.168. But it's fine. It'll never see any of this coming. Alright, so with this basic illustration, let's go ahead and try to build this network. So on desktop number 3, let's go ahead and go into Dynamips. You'll see I've got a version of iOS already set up. I usually build my stuff in a subdirectory so that way I can not have to worry about all these files clashing over each other. This is kind of complicated, but not really when you, I guess, get the hang of it. So this is going to replace the HecNET bridge. So it's going to use the same parameters where it's going to listen on port 5000 and it's going to redirect all of its traffic to 5001. And then the same thing, it's going to need to know the loopback interface. So same thing, this KM test, we need to grab this name here. Unfortunately, we can't pre-configure all this stuff because every time I reinstall WireShark, all these numbers change. So this is going to configure for an MPE 100, 64 megabytes of RAM, just a 4-port Ethernet card with the 2 Ethernet ports connected, one to the UDP to talk to SLiRP, and the other one to talk to the loopback address over PCAP. So I should be able to now launch SLiRP. And then we run the router. Let's just take a moment to decompress and boot. And then we should be able to ping SLiRP gateway. Good. As you can see, bytes received, transmitted, and we get the dot for the first one. We lose our packet in discovery, and then the rest of them it shows that we're running. So this router, like I mentioned, is pre-configured. So the LAN interface is the 192.168.1.1. Our Ethernet 1 talks to the SLiRP library, and because we need to NAT to ourselves, should mention that we have a default gateway set to the SLiRP. Then for the NAT, you need to source by an access list and then set your interface for overload. So everything that matches 192.168.1.0, which is that entire network behind Ethernet 1, is going to go overloaded or behind the address of Ethernet 1.1, which is 10.02.15. So I should be able to do something crazy like ping 10.02.2 source, or ping extended, isn't it? Ping IP 10.02.2, PCAP 5, datagram, timeout, extended commands, yes. And then we're going to go 192.168.1.1, and then just hit enter for all this stuff. And that should have worked. Fantastic. It's not even trying, is it? So we show our IP route. We can see the default's 10.022. Oops. Oh, I guess that's why it's fallen out of sync or something. Sometimes this thing can be very fickle, which is very annoying. So I'm going to go ahead and end that SLiRP and just start another one. Yeah, sometimes it can be very frustrating. We just shut the interface off. No shuttle. See, it's working there. Alright, so let's go ahead and restart our WireShark. Now what we need to do is reconfigure our MIT PC. So let's see, I have a pre-configured settings. So just to save everyone some pain, let's just go ahead and copy it over. And if we look in here, we should have basic IP addresses for the local network. 192.168.1.5 with the gateway 192.168.1.1. Remember, it's going to use octal. So, in case you forgot, octal 300 and hex should be 190 or decimal 192. Isn't this fun? Yeah, fantastic. And then if we look at the hardware, there should be no Ethernet cache. Right, it's going to learn this on its own like it's supposed to. So we can go ahead and just quit out of here. We have to reboot for the changes to take effect. So now we can go ping 192.168.1.1, and we should be able to ping our Cisco router. There we go, 444. And if we look back at our Cisco router, we should go show HARP. And we've learned the MAC address from the MIT PC. So let's try to ping the SLiRP connection. I don't think it'll work, but only one way to find out. Oh, it did get a response. Good, then that works for ping. So, awesome. So I'm going to go ahead and reboot this PC. I'm going to go take a look at our packet captures. So we're able to see the MIT does an ARP for the Cisco router responds, and there's our ping traffic. Everything you would expect to see, and then pinging through the router. Perfect. So we're going to go ahead and stop this capture. We're going to continue without saving. And now we're going to go ahead and try to talk to that BBS. So we just run vert. And this will just take a moment to connect. And there we are. So we're using our 1985 TCP/IP to talk to a modern BBS running Windows 10 x64 over the internet. Isn't that fantastic? So again, going back to our diagram, so this is the MIT TCP/IP box using this virtual Ethernet or loopback interface to talk to the Cisco Dynamips router, which NATs its traffic to the SLiRP library, which in turn NATs to the internet. So if you want to see the NAT traffic, so as we guessed, no, we do not support ANSI. Email address, it doesn't matter. Not that hard to find anyways. I put some ridiculous thing, Ted Stevens and his inner tubes. This stuff we kind of, it doesn't matter, it's just all the joys of logging into a BBS. There we go, so we're at the BBS main menu. So now, if we go back here, we should be able to do show IPNet sessions. Sessions and statistics and translations, right? So show IPNet. I've already forgotten translations. And we can see that we have an existing thing here from 192.168.1.5, that's the MIT, talking to that outside BBS on port 23. using the inside global 10.02.15. So again, it's all the addresses we're expecting, and then if we look at SLiRP, we should be able to hit S, and we can see that there's a TCP session established from 10.02.15 going off to that remote BBS on port 23. So with those addresses, we can see that this machine here, the MIT, connects into the Cisco router. It translates it behind the 10.02.15, which in turn comes into the SLiRP library, which it then translates again back out to the internet. So in the case anyone's ever wondered, you can translate TCP many, many times. It's been useful for a lot of fun hacks. You can see that, again, the MIT thing, it's really not happy about some stuff, and you'll see a lot of retransmissions and push acknowledgements that I just don't think it supports, to be honest. And you see it's a little pokey, but we're online. That's the main thing to see here is that, yeah, we're able to connect into a modern system. Unfortunately, we couldn't talk to SLiRP directly. For whatever reason, MIT and SLiRP really hate each other. But by putting that Cisco router in between, this diagram is able to work. So I hope that's able to show at least some way where you can use other programs to abuse the general networking, from using the HecNET bridge to be able to forward into a user mode library. And I guess one of the reasons why you'd probably ask is, why would you want to do that? Well, if you want to debug or rewrite software, it's a lot easier when it's modular, and this lets you take the networking apart without having to constantly reboot or rebuild the full PC emulation. So it lets you do things faster, and then instead of having to relink things, you can just reconnect stuff onto the network to test different configurations. So overall, it's a lot more faster to deal with. And I guess it's kind of cool in a way to show too that yes, the fact that you can connect with very ancient software onto the internet with ancient protocols. It's kind of neat and kind of dangerous in a way that things like this are still supported. But so goes the internet. So we can close this virtual machine. We can close all this stuff now. I kind of expected to show off how to compile the compilers and then how to compile the libraries, but I see this video is already going on way too long, so maybe we should just stop here, and then I'll do a subsequent video on how to compile this stuff if anyone's interested. I've automated most of it, so it's more so on how to set up your environment, and it's really not that difficult. But I think this is a good enough place to leave this one for now. I've basically shown my objectives, which is to show how to set this thing up, how to separate the networking stack from the program directly, how to do network captures, and how to inject a virtual router into the mix. So I guess that should be about it for this. So hope everyone's enjoyed, and as always, catch you later.